Hello, welcome back to Blender Sushi Live Learning. This episode, I want to show you some kind of experiment that I'm currently doing with Blender and Google Bard. Okay, Google Bard is an AI tool from Google, so it's basically have some kind of understanding of a lot of things, any topics. In this case, I just want to focus on Blender geometry nodes. So I was wondering if we can train AI to understand Blender geometry nodes and whether we can ask questions. So maybe somehow it can give you an answer. So it can build the geometry nodes for you. Uh, so I'm still experimenting, but first of all, okay, this is Google Bard, and this is the topic I'm actually asking about geometry nodes. So first of all, okay, I'll explain the whole thing. I asked Google Bard, do you understand anything about Blender geometry nodes? Okay, it says, yes, I understand geometry nodes, power tool, powerful new tool in Blender, procedural geometry. Okay, yeah, create objects based on mathematical formulas or other input data, right? That's cool. Node-based system, create a network, specific tasks to generate points, create faces, applying modifier, to create complex and intricate geometry. Okay, still under development. It has potential to revolutionize the way we create 3D models. Okay, we know all that. Blah 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 blah. It's actually recommending you Blender Guru, and I think in the future I will try to tell Google Bard to learn from Erin Dale and many other YouTuber or maybe like Twitter artists who actually posted things about geometry nodes. Like talk about geometry nodes, like Celestial Maze. I have a few lists to train Google Bard. Anyhow, it's quite a wordy. Okay, the next one, based on your knowledge of geometry nodes, can you read this visual nodes tree and turn it into simple text? Okay, I'm actually giving Google Bard this simple node tree. It says, unfortunately, I cannot read this node tree and turn it into simple text. I'm still under development, blah, blah, blah. Okay, normally AI will tell you it cannot do it, but you can try to train the AI. So I tell Bart, I will teach you to understand this image. It's a geometry node tree. It has group input and group output. Obviously, the main power of Google Bard in this case is Google Bard actually have I, so you can upload a file which is like image file. So Google Bard is using Google Lens to look at an image and try to understand what the image is all about. I'm telling Google Bard, okay, that image is actually this example node 3. If you look at this, if you know geometry nodes and you look at this very quickly, okay, you can already know you have knowledge. This is this node 3, this geometry nodes node 3 will generate a grid of points to instant geometry on points. Okay, because of these 3 nodes. It's very simple, very basic. This example is actually from Geometry Script by Carson Katri, and with Geometry Script you basically install this add-on in Blender and you can just write this simple script. Sort of, it's not super simple if you don't understand Blender Python. This might surprise you a little bit, but it's very simple. Basically, with Geometry Script you write this Python and you write a functions and you specify the input and input output and return. I couldn't explain this. I think I talked about this in the other video, but basically this script, if I just copy paste it into Blender, so let's do it this way. Okay, I have the 3D view here and I will put a geometry nodes editor on the top here. There's nothing else on the scenes. I already have Geometry Script installed, so if I copy paste and then run this, it will actually create a geometry nodes in the background. So on this default cube, if I apply geometry nodes modifier, apply the nodes that we just created. Suddenly the default cube disappear. Why? Because why is this? But we have these nodes at least being created. I just need to put this simple parameter 5 by 5. Okay, we have the default cube arranged in the grid, and the grid, actually the size, what is the size of the grid? We didn't specify the size of the grid. Oh, okay, it's based on this as well. Okay, it should be separate, but anyhow, I can make the cube smaller. Now the cube is arranged in the grid, so we can have monkey head as well, and monkey head can be arranged in the grid as well, maybe 3 by 3. Okay, we have monkey arranged in the grid of 3 by 3, and we can increase the grid, and so on and so on. Okay, the geometry nodes work, and the script, geometry script works because it creates geometry nodes. Okay, blah blah blah. However, okay, the node 3, go back to BART. I'm telling BART, I will teach you to understand this image. Previously, it doesn't understand this image, but I'm telling Google BART, this is a geometry nodes node 3. It has group input and group output. Obviously, like if you are training a human being, there's a group input and there's group output. Okay, and we are using, we are applying geometry nodes using modifier, and then that mesh will be used as an input, and then in between this there's this grid, mesh to points, and instance to points, and there's all these connections going on, right? Yeah, I'm telling just the obvious to Google BART. The connections, I didn't explain anything about the connections, but in this case it's really super simple, right? Just the green dots, this is the mesh that's being passed on the nodes. Create a grid, and then turn the grid into points, and then use these points to instance the original input geometry. Yeah, and so we get the grid. It's very simple, very basic. So Google BART says, I understand. Thank you for teaching me. Okay. Because I'm telling Google BART, 3 nodes in between group input and group output. There's a grid, mesh to points, instance on points. Okay, all right. It's understand. Group input. Okay, and it's trying to describe what it understands. So there's group input, there's grid, mesh point, instant on points, group output. Okay, it understand the nodes, and this is very important starting point. Yeah, there's lines connecting the flow of data. That's correct. The data flowing from group input node to the grid node and then to the mesh point, and then yeah, okay. Right, and then the next thing I asked, using the knowledge above, I want to arrange instance to represent points of a circle. And how would you draw the nodes using text? Actually, most AI model, including ChatGPT, at some point it will actually give you this type of example. Maybe not so much knowledge on geometry nodes, but it understands shader nodes. Shader nodes can grow like in complexity. I know but in this case, we start with just the most basic, right? And Google BART told me, okay, if we create node 3 using text, you can maybe do it this way. Grid, mesh to point, instance to points, and a circle. This is obviously wrong. This is wrong. Because we know if we want to arrange points in a circle, we actually don't need grid anymore. We just put a circle mesh and then mesh to point, instant on points, right? I told that is not correct. I told BART, you can just use circle before mesh to point. This will generate points for instance. And then it's correct itself. Now we have circle, mesh to point, instant to points. Cool. Okay. The next one, instead of circle, I want to have random points. Now BART actually understand random points. Random points, mesh to points. Now I want to arrange points. Now instead of random points, I want to have monkey head geometry to instance my geometry. Please give example node 3. Instead of random points, I want to have monkey head. Group input monkey head match to point instant. This one is actually correct. Monkey head loads monkey head geometry, and yep, this one is actually correct. It gives additional tips for creating node 3 for instant monkey. You can use instance transform, you can instance color and an instant random to add randomness to the instance. Okay, I will try to kind of expand this idea, but anyhow, we have this grid and we have the geometry nodes that's being created using geometry nodes. At some point I will try to train Google Bard to understand geometry nodes, geometry scripts, so we can actually draw these nodes using script, so it's automating some stuff. Currently it has this grid with the width and height. Okay, now if I want to have a circle, don't use curve circle, use mesh circle in this case, because we just want to use mesh and mesh to points. Circle have radius, correct? And then indeed this is correct. The mesh circle and then mesh to points, this is actually quite logical, and Google Bard indeed give that example after I corrected. Circle, mesh to point, instant to points. Okay, that makes sense. If it's random, Google Bard actually only say random points, mesh to points. Do we have random points? We actually have random value, right? Random value. We have this random point is I don't know where this came from. Maybe this is from BugAPI add-on. I cannot remember. It could be from Arindel as well. Because this random points is actually a group, and inside this group of points we actually have random value plug into the position of point nodes, and the output of this points node goes into the instance on point. This is a group node. But if we replace this circle and then just plug this there, we got, it seems like we don't have anything. What if we plug this geometry there? We have random points of the cube, of the default cube, which is interesting, right? But I mean, we obviously don't have random points, but the fact that we have it, when we shift A and then search for random points, this is kind of weird. I think this is from BugAPI. I think I have BugAPI installed, and BugAPI modifier comes with some bunch of geometry nodes group. So in this case we are, I don't know, this is pretty cool, I guess. We have a monkey head and we can assign geometry random points. Okay, we have, we can have instance of Susan head. Susan heads using the points of Susan being scattered. Yeah, so this is like a multiple layering of nodes. It gets a little bit complicated, but it's interesting. In fact, these random points, of course, we can randomize the seed as well, you know. Anyhow, this is random points. We supposedly don't use this instance on points. We simply just want points. And then we don't need this mesh to points anymore. Just plug that in. This is supposedly what we need to create. So obviously, I mean, Google Bard do not understand there is no random points nodes. We just need to have a random vector plug into points node. Hey, we do not have random points node in geometry nodes, but we can use random value vector and points node. Can you recreate the node 3 in text to make random points instance? I mean, my prompt here might confuse Google Bard a little bit, but apparently it understands it. See, it understands it. Random value vector plug into points match to point. This is actually correct, even though it's super basics and highly simplified. You know, this is what's going on. Okay, random value, and this should be a vector, right? We manually change this to vector, minimum maximum value. This is the value. Output is vector position. It's not geometry. We cannot just plug this into position. I mean, you can do it this way, but that's not correct. You want random value plugged into points, obviously, point position. So we have this ability to plug the points there. Okay, I know. Google Bard also made a mistake. Point and then match to point, because point is a point cloud. We don't need to match to point because the output of point is already point cloud. We do not need mesh to point node before instant on points. Can you fix this? Random value vector point instant. Okay, it actually corrected, right? We are training Google Bard to do this. Now, I want to ask something that Google Bard not yet answer. We don't need this mesh to points in this case. So since we already have point cloud from points, what if distribute points on faces? Okay, we haven't used this distribute point on faces. Okay, yeah, I mean create randoms. You can randomize the seed. Distribute points on faces. We obviously want to pipe this original mesh. We want to distribute points on face. Okay. Now modify the node 3 so I can distribute points on face based on my original input geometry. Okay. Modify the node 3 so I can distribute points on face based on my okay. You know, our original geometry is either the default cube or Suzanne. We know there's this distribute points on faces node, which is, you know, it's super handy. It generates points, right? It generates points. Just scatter it, and then these points can, of course, obviously can be used with instant on points because it's super obvious. And then as the instance, we actually want to instance itself. Google Bard, group input, distribute points on faces, instance on points, group output. Okay, I need to explain the whole thing again. Distribute points on the faces of the input geometry, the lines connecting the nodes, the flow of data. Yeah, it's just always we keep in mind is the node 3 of geometry nodes represent the flow of data. The data flows from the input. Okay, it makes sense. Now, instead of using geometry as input, I want to instance cylinder and randomize its instance rotations. Can you draw node 3 in text to explain this idea? Okay, so use randoms. Group input cylinder instance on points random rotations. Okay, this is so funny, right? Okay, I still have to train Google Bard in this case, even though it's not 100%. It's not 100% wrong. With instance on points node, we can have points and instance inputs. I want the point to come from original input geometry, and the instance is cylinder. Then we don't have random rotation, but we have instance rotate node. This is what I'm trying to do. We have distribute points on faces, obviously, but the instance using the original geometry, and don't do this. We want cylinder. Okay, this is if we do it manually. Okay, it's obviously using we have random cylinder on top of the original geometry. Okay, it's not the most interesting. However, here rotate instance rotations, right? We have instance translate. We have rotate instances. Group input, distribute points on faces. Obviously this single line doesn't work as well. Okay, instead of instance rotate, please use rotate instances. Rotation. Okay, we actually need random value, right? Random value of vector plug into the rotations. It's randomized the rotation between -1 or 1, or between minus tau and tau. It should be half tau, but it should be minus tau divided by 2. It's become like pi, and then this is tau divided by 2. Okay, random cylinders on points on this object. Okay, now a single line text representing this node 3 is not enough. You see, we have to explain there are two inputs going into instance on points, which is points from distribute points on faces and instance from cylinder. How would you draw this? How would you explain this as text diagram? A single line text representing this node 3 is not enough. Oh, it's not enough. You have to describe with text that there are two inputs going into instant on points, which is points coming from distributed point and this an instance input from cylinder. Okay, okay, this is actually this is this makes more sense. Okay, group input going into distribute points on faces, which is exactly this, our original geometry, distribute points on faces. And then with instant on points, we obviously have the cylinder goes into this node instant of points, but and then the points input from. Okay, now Google Bart actually understand this a little bit better. I think the whole conversation and chat actually teach Google Bart of all of this. This is what it means by, I think, prompt engineering. We don't know. We starting to teach Google Bart to understand this a little bit better. Anyway, so now instead of cylinder, I really want random size cubes in XYZ as input for my instance object. Can you make node 3? Can you modify the node 3? Group input, distribute points on faces. Okay, there's this weird things with cylinder coming after, which is anyhow the instance from cylinder, input from distribute points. Okay, this is actually makes sense. And then instead of cylinder, rotate instances. Sure, I can modify distribute point on faces, random size cube, size random in, output random size, blah, 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 goes rotate instances. This kind of makes sense, even though, yeah, random size cube. Okay, random. Since we don't have random size cube, what we really want is a cube that goes into the instance, but the cube needs to be random in size, right? In order to make this random in size, you use random value vector. And this is the weird thing about geometry nodes. You can do this only if you have this ID, and then the ID you have to have a value, which is the value should be integer normally. Okay, at least we have this value in the ID. We can randomize the seed later. So more or less we have random size cube and we have random rotations, maybe scale instances, make this smaller. You might, however, notice in this case, okay, this is a basic example, random instances, but at least we are using Google Bart. We do have random size cube, but it's randomized over here, and it's not randomizing the instance. So what we really want is actually randomize the value over here. scale instances, scale. So we have cube coming in, and then we're randomizing the scale over here. So each cube should have different scale, which is, I think this is correct. Yeah, I think it should be correct. So at this point, it might. So what we, okay, my conclusion from this so far is actually we really need a way to write our node tree as a text. That's first, okay. And then so Google Bard hopefully can understand, if we ask like a totally different question that's a little bit more complicated, hopefully Google can describe it a little bit better, and then somewhat we can incorporate a geometry script for this. Can you turn the nodes? Can you turn the text above representing node 3 as geometry? Oh, let me ask, do you know how to write Python for geometry script by Carson Katri? Do you know how to write Python for geometry script? I do not have enough model. Oh, right. This is gonna be. Can you rewrite the node 3 above? Do you know Blender Python? Can you rewrite the node 3 above as Blender Python? Can you rewrite the node 3 above as Blender Python? Okay, it says create random size cubes size. In this case, it should make like a Python to create a random cube, I believe. Points not found. For every points in points, create a mesh of random sized cubes on the points. For point in points, what's the point? This code will create mesh of random size of cube on points. What's the points? Points not found. Oh, anyway, I think it's starting to kind of go far from what we really want. But what needs to happen actually? We should provide geometry nodes script. Below is Blender Python geometry script that creates node 3 to make points on grid and instance. I'm teaching Google Bard about geometry script, which is a Blender Python. It's a now modify the script so instead of grid please use circle mesh. Obviously, this script, if we okay, repeat circle, I think this script might not work because we just say repeat circle. Obviously, there is no circle. Circle mesh. Mesh circle. Mesh circle. Output is mesh. Mesh circle. Mesh circle with the radius of something. Mesh circle mesh to points. I think this should be correct. Look, okay. I will try to think on why this doesn't work. But mesh circle radius is correct. Mesh to points. It's actually starting to make sense, right? Because previously we tell Google Bard, okay, geometry, there's a width and height. This is actually very interesting because Google Bard seems to understand Carson Katri geometry script. And then we tell, okay, instead, circle, if you say circle not defined. Circle not defined. What other possibilities we have here? Circle not defined. There is no circle. Maybe there is a circle. Now it's starting to try to create other things. We have example of where city builder mesh to Lego and repeat grid. I think in this case I will have to study the API a little bit more. How to search node, searching node, circle, nothing. Geometry, no, geometry script, okay, circle, curve circle, mesh circle, mesh circle, vertices, radius, mesh circle. Have no attribute mesh. Resulting is mesh geometry. Okay. Let's get rid of everything. I think this one is correct. So if we start with fresh Blender and we use text editor, paste it here, run this, geometry nodes, there you go. Google Bard actually helped to create this. It's just the one thing that it doesn't understand is what it doesn't need to have after this circle. It doesn't have to have this mesh and then mesh to points. In case of grid to mesh and then mesh to points, it's a I don't know why with circle you don't need to have this mesh in between. Actually, Google Bard didn't make mistakes. Logically, you would actually write it that way. So, okay, so I think my attempt to create this, attempting to train Google Bard to understand geometry nodes, sort of working, sort of. See, mesh circle, mesh to point. And then now our logic is starting to think, right? Instead of circle, we already use grid, we already use mesh line. We already use mesh circle. How about mesh line? Okay. Instead of now geometry script. Or what if instead of circle we use line? Yeah, I think Google Bard knows the repeat line. It says, okay, it's creating this geometry nodes, geometry script. It says repeat line, create it. No modules, names, geometry nodes. What? We have geometry script. From geometry nodes import. No module name, geometry nodes. No module names, geometry nodes. What? Okay, with repeat circle. Okay, there's a bug. There's a bug. Okay, Blender 3.6. Create a text. Back to our this. We want to repeat line. Copy. Geometry script. That's weird. Okay. From geometry script. Okay. We don't have geometry nodes module. It is actually called geometry script. Google Bard, large language model, Google LLM. Okay, instead of geometry. Okay, how about now? How about now? From geometry script. Line is not defined. Do you mean line? We need to check with the API. We need to check the API and line. There's a curved line and there's a mesh line. It's okay, it's called mesh line. Mesh line. We don't have line. It is actually, please fix the code. We don't have line, it's actually mesh line, please fix the code. So in this case, Google Bard actually is starting to dream. I mean, we imagine things a little bit. It has no attribute mesh. Let's get rid of this mesh. Boom. Okay, now it actually works. You can't see it. Repeat line actually works. The length is not connected, which is, so there's something wrong with this. But the line's not connected. Mesh line, mesh to points, instant on points, geometry coming in. Our geometry is cube. The line, what's missing here is really the line, this offset. The offset. The length of the line is the offset. Okay, if it's a curved line also they don't have the length. I mean, we could have used curved line. Curved line is, however, it's not a mesh, it's type of curve. This is, but you need to resample the curve. Yeah, if it wants to use the curve length, this is what's going on. But Google Bard, of course, don't understand that mesh line doesn't have length, so it's trying to connect it this way. It doesn't have length, so the length is really supposed to be z, the z-axis. However, we have count. Okay, tell Google Bard, with mesh line we don't have length parameter, but we have points. We have count. Please modify. Obviously, we can, at this point, we can start to read the code. Yeah, see? Mesh count. Again, it's complaining doesn't have attribute mesh. I don't know why it's doing that. Boom. Right? It works. It really works. The mesh line, mesh points, it's really basic, but I'm training Google Bard to understand the whole thing. I think at this point, Google Bard is a little bit smarter. And we also, as a human being, it's a little bit smarter. So really, in this case, it's super basic example. We are instancing mesh on points of mesh line. Obviously, there are other mesh primitives. Cone, cube, cylinder. Okay, grid is cool one. Mesh circle is cool. Mesh line is cool. We can try cone or cube or cylinder. How about if we want this volume cube, and then points on volume, distribute points on volume. We want this. This is points on line. points online works. Okay, it works. Google Bart understand it. Volume cube and distribute points in volume. Okay, now Google Bart. Okay, volume. Let's do this. I want, instead of line, I really want points distributed inside volume cube. Please modify the geometry script. Repeat cube. Points distributed inside volume cube. Huh. Okay, this is might confuse a little bit the volume. We have distribute points in volume. We actually have node n volume cube. Check with geometry script API and modify the script. I think Google Bart will complain. Volume cube distribute points. Okay, let's try this. Actually, it might work, it might not work. Repeat cube. It should be like repeat volume cube because we are using volume. Run this. Repeat volume cube. Okay, look, we have volume cube, distribute points. This actually works. Amazing, right? It's pretty amazing. Yeah, pretty cool stuff, right? You know, at this point, you know, instance some points we can always okay, make instance, make realize instances, and then mesh to volume to mesh. We can do that sort of thing. But from this experiment, you can see Google started to understand the whole point, which is really weird. It's really, we just train Google Bart to understand geometry nodes. I don't know. Maybe at this point we can actually take a screenshot of this, upload a file, go to our desktop, now with your understanding of geometry script, look at this image and recreate it using geometry script as code. With your understanding of geometry script, look at this image and recreate it using, we as a human, obviously, with our knowledge of geometry script, sort of, we can actually remake this using geometry script manually, okay, using our brain. Sure, I can help you with that. The image shows grid of points with a sphere instance on each point. Grid match the point instance of on points. You mismatch the volume. Oh. You missed the realize instances match the volume. realize instances mesh to volume and volume to mesh in the code after instance on points. Please fix that. You misrealize instance mesh to point. Now instance sphere. I don't know. Let's try this. File name. We are assuming that the Google Bard will understand it completely, but obviously it's not. Sphere is not defined. Sphere is not defined. Please use sphere. Sphere. Icosphere. Icosphere. Sphere is not defined. Please use icosphere. In this case, here I don't know what's gonna happen now. Slightly blindly running the code. Yeah, slightly blindly running the code, but in this case I should actually stop and maybe try to train Bard a little bit better at this point. Maybe there will be another video. Obviously it's trying to make the grid and then instancing the points on the grid and then instancing icosphere and then realize instances. Yeah, I think it's doing something weird at this point, slightly going somewhere. But at least in this video I recorded the whole process, and then hopefully this is useful. You can try to train Bard this way. So it's interesting. Hopefully, yeah, Google Bard starting to wonder if I'm actually a bot, because I keep going with this. But anyhow, it's sort of almost work. But at this point you really want to stop and actually understand geometry script a little bit better, so you can train Google Bard. In the future we can probably just ask Google Bard, hey, I want to make like a pyramid, pyramid and a stack of cubes to draw the pyramid, and you can just script it. Google Bard will script it for you. Okay, so that's the idea. Hopefully you find this useful. Thanks again for tuning in. I'll see you next time. Thank you.